in Geometry Review Lesson 1, which is what I am starting with today, I have done the odds up through number 13, so I'm going to go over these with you real quick. And I'm going to show you some logic that you can use to help solve these problems. So the first question states, the difference between the supplement and the complement of an angle is always blank degrees. Well, the first thing we can do to find this is we can say, let's come up with an angle. So let's do 60 degrees. Okay, so I'm going to do 180 minus 60, and then I'm going to do 90 minus 60. And then I'm going to subtract its complement from its supplement to find out how many degrees are between it. So this is going to be 120, and this is going to be 30. So now if I do 120 minus 30, it's going to give me 90 degrees. Now, the reason, one of the ways that you can know this is simply by doing 180 minus 90 gives me 90 degrees, but you can test this out with a bunch of different angles and see, but it's always going to be 90 degrees is the difference between the two. So if you forget how to find one of these and you're like, oh man, I know complement's 90 degrees, you can find the complement and then add 90 degrees to it to find the supplement. Okay? The distance from a point to a line is the length of the blank from the point to the line. So if I draw a point and I draw a line, the distance from it is actually going to be, you guys remember this? It's the perpendicular. Okay, so it's the perpendicular from the point to the line. And this is one of your definitions we went over back at the beginning of the year. So a lot of this is going to be coming from those beginning notes. So make sure that you are just paying attention to all the little details here, because we have done all of this stuff before. Okay, so here we go. Number 5, if the opposite angles of a quadrilateral are blank, the quadrilateral is a parallelogram. Okay, so if it's a parallelogram, that means that it has two sets of parallel sides. So I know that side's parallel, that side's parallel. This side is parallel to this side as well. So if they are, does anybody remember this? And I know you guys can't respond to me right now, but it is if they are equal. Okay, so it's if they are equal. That's our big key word right here. And it was just one of the definitions of parallelograms. It was that the opposite angles are equal. Okay, moving on to number 7. To determine a point equidistant from the vertices of a triangle involves bisecting the blank of a triangle. So if you remember, this is what we were doing when we were doing inscribed and circumscribed circles. So to do equidistance from the vertices, well here, let's see. So I'm gonna pretend I'm bisecting these angles. So I'm gonna bisect the vertex of each angle, okay? Now, if we look at this, we can see, is it equidistant from all of those? I don't know. So let's try and imaginarily bisect the sides. Also, I'm sorry if you can hear my kids in the background. I'm filming this while they are awake. Okay, and let me try approximately here. And then let me try, okay, here. So now, if we look with this, this is how we inscribe a circle, and this is how we circumscribe a circle. So with circumscribing the circle, you want it to be equidistant from all the vertices. So we would actually bisect the sides of a triangle because we need it to be equidistant from everything. Okay? Number 9 is on the back. If each exterior angle of a regular polygon is 72 degrees, the number of sides the polygon has is blank. Now, if we remember, the exterior angle is actually equal to the central angle, which means that 360 divided by the number of sides equals 72. So I can actually just switch this here and I can do 360 divided by 72, and I've got my calculator. I have the big one this time, so I'm going to do 360 divided by 72, and I'm going to find out that this is actually a pentagon, so it has 5 sides. Do not forget this little tidbit here. So the exterior angle is equal to the central angle. Okay, two isosceles triangles have equal vertex angles. If their bases are 2 and 3 inches, the ratio of their area is blank. I'm going to pause for a second and I'm going to remind you that if they have equal vertex angles, that just means that all their angles are equal, which means they are similar triangles. So for this, the ratio of their sides is 2 over 3, which means the ratios of their angles is 2 squared over 3 squared, which is 4 over 9. It won't fit in the blank like that really, so I'm going to put it there. And then finally, we have our last problem. So two parallel lines are cut by a transversal. If one of the two interior angles on the same side of the transversal is 3 times the other, the number of degrees in the larger is blank. So I'm going to draw two parallel lines. It actually really helps right now to have lined paper instead of a marker board. I'm going to cut it by a transversal, which means I'm just going to take a line and go doop. And it's going to tell me that one of these is 3 times the other, because I'm going to look on this side, okay? Because they're on the same side of the line of the transversal, and they're the interior angles. This is my larger one, so I'm going to put 3x here, and I'm going to put x here. Now, I know that 3x plus x, because they're on the same side, they actually equal 180 when added together. So that's 4x equals 180. If I do 180 divided by 4, I will find that my smaller angle is 45. Now, it wants the larger one, so I have to put this back in for 3 times 45, and it's going to give me 135 degrees. As my final answer to that. So see how a lot of these problems really just deal with using logic and using a lot of information you've already been given and that you already know. Okay, so with that, I'm going to continue on Monday with this review lesson 1. One of these lessons is going to go by fairly quick, so I'm going to try and do all of that in one video, but I'm going to take a little bit longer on this one. You have an assignment up. It's 2 through 12 even, so I will have that typed up for you. It'll be in your classwork section. You're going to have to use some logic because they're not going to be the same exact problems, but hopefully you can see how I've sat down and I've worked out some of these problems knowing what we know, and you can look at it and you can say, oh, hey, that's actually similar to something that we did in Unit 2 or something. So use what you know to solve these problems. And if you have any questions, let me know. Please respond to my responses so that I know you understood the problem after I explained it. Thank you, and I will see you guys on Monday.